All right. Happy Tuesday. How's everyone doing? Look who dropped by the office this week. Maxine wanted me to let you know that you should come to office hours. You can see the office hours on my door here. So drop by Wednesdays, 10:30 to 12:30. It was nice seeing everyone who showed up last week. Yeah, feel free to stop by. You all get some nice sunlight this weekend, hopefully. I know a few of you did homework for me. I hope that wasn't many of you. Hopefully you can get all of your homework turned in before the weekend so you can live free. Let's see, housekeeping. So I just posted homework, 1.5. That's due on Friday. As always, if you need an extension, you just email me and you can turn it in on Monday. Let's see, and then we have our first mini exam on Tuesday next week. So first thing on Tuesday, a week from today. I'm going to post more information about that, including a mini exam demo. So just me running a mini exam on camera. So I'll just talk you through my thought process as I try to answer each one of the questions. And if there's enough petition for it, we can. I'll try to schedule a review session, but you let me know if that's something that might be helpful. I think we won't hold it for this first one, but we might hold it for the next one. So drop in for office hours and let me know if that's something that might be helpful. And then your homework should be back to you in the next 24 hours or so, so you can expect that. Let's see. I think that's all the housekeeping. Anything I missed? Oh, attendance. How many of you have used Top Hat? Okay. If you haven't used Top Hat, we can chat about it after class. This is just a way for me to give you a little bit of extra reward for doing your job and showing up. So 1% at the end of the semester comes from your attendance, on top of the 100% that comes from everything else. So this is just a little extra gift. So this is the attendance code. You all probably know what to do with this. So last week, on Thursday, we left off talking about panel data, which is one of my favorite topics. So we walked through this last time. We talked about long format data. So this was, we had coffee shops and then we had transactions just in sequence. And we called this long format because we were just basically stacking each of the individual observations just one after the other. So we have each of the transactions just getting listed. We have the hour of the day, and then we have the coffee shop. And you'll remember there were 3 coffee shops. We stacked all of their transactions. We didn't break them out by coffee shop. We just labeled which coffee shop the transaction occurred at. And then we also had wide format, which we haven't spent as much time on. And this is where we're picking up today. So wide format data, instead of stacking each observation one after the other vertically, we're just giving each year, so the time component gets its own column. So we have each row representing an entity. In this case, this is the country, and then each one of the subsequent columns is just a year. And so we're going to work with this data set most of the first part of class before we jump into part 1.5. But I have some extra questions I wanted to ask you that we didn't get to last time, which we are going to talk about today. So this is our wide format where instead of stacking vertically, we're sort of orienting it horizontally with the time component represented by separate columns. Okay, and then we walked through this example where we were thinking about where to hire a barista, and we had this data set, and you answered a bunch of questions about this. So we talked about separate coffee shops and transactions by coffee shop. And this gave us one view of our data set. So this was which coffee shop is busiest, if we're just looking at like day-to-day aggregate transactions. But it wasn't the kind of view of the data that we wanted for our question, which was essentially which shop shift was the busiest. So another view we took was to look at time. We sort of aggregated by time. So we counted up each hour as its own bin and then created a histogram of that data. So this gave us a picture, sort of as you'd expect, coffee in the morning is most popular. And so what we wondered was the busiest shop in the morning the busiest? And it turns out the answer was no. We walked through and we said, actually, with this terrible figure, we can see that coffee shop C, which was not the busiest shop, but coffee shop C was the busiest shift in the morning. So coffee shop C in the morning was the busiest shift. And then we said, this is not a great figure, how can we improve it? Well, so we have the three lines, the three coffee shops through time, each one having a separate sort of time component. So we just plot this as three line graphs. And this is what we did with Seaborn pretty simply. We did it in Excel and in Python. So this was panel data, right? So we have each coffee shop through time broken out by coffee shop. And this gave us a picture of that panel data. And this is one incredibly powerful tool we have to understand panel. It gives us more than just the cross-sectional variation, and it gives us more than just the time series variation. It gives us both. And this is a classic picture on panel data. Okay, we walk through some of the summary here and the exercise. And we reproduced some of these things, mainly the line graph here. And it's a little more complicated than what we've done with figures before. There's a lot of entries into the hist plot, but this is the general picture and the kind of code that we can do it. We also did it in Excel. There was a similar question on your homework, creating multi-line graphs, which I think was a little simpler than this, but still creating these kinds of graphs. Okay, any questions here? So that was the first part of panel data. We talked about long format, where we just stack each observation one after the other, and then we just keep track of which entity corresponds with which row. But the second data set we started working with was with this coffee consumption per capita data set. So we have many countries around the world drinking coffee, and we're thinking about their coffee consumption through time. And we just have separate columns for each one of the countries, or separate rows for each one of the countries with the columns representing the time, the year. And if you'll remember, let me just bring up that data set so we can remind ourselves of what that looks like. So this was coffee per capita. So this is the picture of the data we had at the beginning. We have each of the country codes in a column. So these are for each one of these rows, we just have multiple observations for their coffee consumption per capita across time. And so you can just see, as we move horizontally, we're moving through time, which I think in my mind anyway, sort of corresponds better with a time series, where we have each one of the rows, each one of the columns representing a different time. But we have two formats of panel data, and each are equally valid. Okay, so this is the data we're working with for the last part of part 1.4. And I walked you through this picture from last time. We said, here's a histogram of coffee consumption per capita, where you have the horizontal axis representing just the coffee consumption, and then we're making a histogram binning each observation, each country into essentially a bin, and then we're just counting coffee consumption per capita using a histogram in the standard ways. And our main question here is the world drinking more coffee? We started answering some sub-questions. None of them we can answer with this histogram, right? This gives us no picture for thinking about changes through time. This is just a snapshot, cross-sectional variation in 1999. So we said, what if we add a second histogram on top of this? So I think two histograms on the same figure can work, but it doesn't really work that well for this question. We have 1999, and then we also have 2019. So we have 20 years between these two observations, these two snapshots. And we tried to answer the main question for us, is the world drinking more coffee, using this figure. And the answer here was, well, it looks like there's probably more coffee being consumed, but these histograms don't give us a great perspective. It's pretty hard to see what's going on here. So the first thing we did was turn to a multi-box plot. I think this made the answer to our question much clearer. From this picture, we saw a shift out in coffee consumption per capita, at least among the countries that we're observing. Okay, so we have this nice picture. Coffee consumption per capita seems to be increasing between these 2 years. So this sort of answers our main question with a general yes. But the remaining part of part 1.4, thinking about panel data, we've devoted to trying to understand the sub-patterns. So what's going on within this outward shift in coffee consumption per capita. One of the things we did last time was break this this shift in coffee consumption per capita into 5-year increments. So we're looking at 20 years. What if we add sub-years? So this is where we started. This was the first sub-picture. We wondered, was there a big jump in any one year? Or was there just a steady, gradual increase in coffee consumption over this time? And the short answer is, it looks like it's pretty steady. So we broke this into some sub-questions. We looked at the medians, tried to find, coffee consumption per capita under a certain threshold. We looked at the biggest jump in any 2 years, any two periods, with the biggest jump in the medians. And then we looked at the minimums. It seems to be an increase in the minimums over time, and then the maximums over 20 years have definitely gone up, but it's not a consistent pattern. And then we asked some more complicated sub-questions, like all of this. And this brings us to where we are currently. We've walked through these multi-box plots and answered these kinds of questions. For the sake of time, one thing we could do, and if you want more experience working with multi-box plots, I have a nice example here, a nice exercise to work through multi-box plots with this data set. So it's basically reconstructing these figures. But for time, we're not going to do this in class today. Everyone rejoices. Do you all like multi-box plots? Anyone love them? Okay. Anyone hate them? Hate's a strong word. I think I'm sort of ambivalent with them. I think they can give us a nice picture, but they're not always the greatest tool. They're not that, I think, yeah. When I look at them, I just, for some reason, don't love them. When I look at her, I do love her. Much more than a box plot. Okay. Did I tell you I had a child recently? I don't know if I mentioned that. So I left you with one question. So if you want to, you can go through and try to construct a box plot with this code. We'll save that for non-class time. What if I gave you this question? In which year did most countries increase their coffee consumption per capita? Discuss this with your neighbor. We'll take like 30 seconds to a minute here. I want you to think about how you might answer that question with this figure. And in the process, tell your neighbor something very boring you did this weekend.
Right. I would say that's the best guess, but a guess isn't good enough. Not necessarily.
Okay, someone answer this for me. What do we know about the answer to this question? Luke.
Can't answer it definitively with this visual.
Okay.
Our best guess was from 2009 to 2014 because of the median shift. But
Okay.
while that might suggest it, it's not. We can't be certain. We have to do further analysis.
Okay, so one thing Luke is saying here, first off, we can't be definitive about the answer to this question. We're not able to track which observations are which across two different box plots. Luke is also saying maybe the biggest shift happened in like 2009 to 2014 because of the shift in the medians, which is a reasonable thing to guess. What else? Yeah, Matan.
I would guess from 1999 to 2004, because that's the biggest shift in like quartile 1, quartile 3, which is like, no, I'm not even looking at that.
Oh, here.
Yeah, that's like, that range is where most of the people are. Most of the
Okay, yeah, so 50% of countries are below the median, and Matan is saying we have this actually pretty major shift up in the Q1 from here to here. And so maybe it's actually that year. Okay. What else? So we've concluded we can see shifts in the quartiles using these box plots. And we have some picture of the data points behind the quartiles using the strip plots that I've added some color on top of the box plots. But we've also concluded that because we can't track which data point is which across any two box plots, we can't actually answer our question. This picture doesn't allow us the visual to answer our question. I think I might have mentioned what we can use to answer this question. And I mean, the slides are on the website, so maybe some of you have seen this. Anyone know what we're doing next? Or if you can read my mind. So we can't see the answer to this question. Instead of asking the question I just asked you, next we're going to ask this question. So instead of breaking it into smaller parts, we're going to look at a very big interval. We're going to go from 1999 to 2019 and ask how many countries increased their coffee consumption per capita during that time. This, again, is a question we can't answer with this figure because we can't track where this individual country landed in 1999. We don't know if they increased or decreased their coffee consumption. It could be that this point ended up out here, became the maximum, but it could also be that they became the minimum, and we just don't know. So let me show you my favorite visualization tool, and that is the scatter plot. So instead of plotting two box plots, all we're going to do is plot each individual country as one data point on a two-dimensional graph. The horizontal axis represents coffee consumption per capita in 1999. And then on the vertical axis, we have the same entity, the same country, but their coffee consumption per capita in 2019. So each one of these data points represents one entity, but at two different times. What we're going to do for the next few minutes is just try to examine how to interpret these kinds of figures. This gives us a very different perspective on the same data set that our box plots did. This is the same data as this. We're just representing it in a different way to give us a different, an answer to a different question. This picture was good at telling us whether the distribution had shifted, but now we're wondering which countries increased their coffee consumption, which is something this box plot cannot do. Okay. So I'm going to ask you a couple of questions here. So we've plotted all of these points, and each one represents its own country at two different points in time. The first thing we're going to do is represent no change as the 45-degree line. So if a country has not changed their coffee consumption per capita, they'll be at the same level of coffee consumption in 2019 as they were in 1999. My jokes fall flat. There are errors in my slides. I can't pronounce 1999. I can write great Python code. Self-deprecating humor doesn't even work, so I'm not even. So we've a 45-degree line here, which represents all of the possible combinations of coffee consumption in 2019 and 1999, where we have not changed our coffee consumption per capita. Okay. Any questions here? So if you're consuming 0 coffee per capita in the first year and 0 coffee per capita in the second year, you'll be at 0, 0. And if you're consuming 20 kilograms per capita in the first year and 20 kilograms per capita in the second year, you'll be at 20 kilograms per capita. You run a line up until it hits 20 kilograms per capita in the second year. And that gives us the point representing the change in our coffee consumption per capita. Because there's no change, that point is represented on the 45-degree line. Okay, so a couple of sub-questions that we can answer with this type of picture. We could ask how many countries increased their coffee consumption per capita between these 2 years. And I gave you the answer if you were looking at the slides. But someone tell me intuitively, how would we think about identifying the points that have increased their coffee consumption per capita during this time? Like, how are we using this figure to answer that question, Ruby?
Anything
Okay. And why is it to the left?
Because it would show that, I don't know, like the line shows how things are constant.
Yeah.
So if they increase, then you say, it would have been higher.
Okay. Yeah, this is very nice. So Ruby's saying to the left or above this 45-degree line. Anyone else want to try to maybe offer a systematic approach for thinking about why it's above or to the left? Yeah. Is it Darren?
Because the line offers like a one-to-one increase.
Yeah.
Any dot that deviates closer towards the y-axis, which represents like a higher increase in consumption in 2019 in comparison to in 1999. So
Yeah.
in theory, any line or any dot that's under the one-to-one ratio also means that there's more consumption in 1999 than there is in 2019.
Yeah. So nice. So we will use this 45-degree line to find not just increases, but also decreases. And what Darren's saying essentially is if we're at 8 kilograms per capita, for example, we can look at the point that corresponds to no change, which is on the 45-degree line, and then just find something that's higher than it. And all of those points are going to be in this upper triangle. So it's going to be either higher or to the left. Okay, so the next question is, so we have this picture, which represents all of the points that have all the coffee consumption, all the countries that have increased their coffee consumption per capita during these 2 years. And this is the answer to our question. We can easily see it with a scatter plot between 2 years, using the same measure in the 2 years, and then we can just scatter the 2 values, one column versus the other, in a scatter plot. The base year, the starting year, is the horizontal axis, and then the new year as the vertical axis. And this answers our original question. We can just go through and count up the number of countries that have increased their coffee consumption per capita during these 2 years. Okay, and then as you'd expect, we can see all of the countries that have decreased their coffee consumption per capita as the ones below the line. So just like before, all we need to do is draw a line from where we are. So we pick one of these countries, and we draw a line to the horizontal axis. And if we're below the 45-degree line, so if this line hits our point first before it hits the 45-degree line, then that tells us that we've decreased our coffee consumption per capita, because we haven't actually, we're not at a level of coffee consumption per capita in the second year that we were in the first year. Okay, any questions about this? This may seem simple as a tool, right? We're looking at 2 different years, we're plotting the same measure in both of those years, and we're plotting it on a 2-dimensional graph, a scatter plot. But this is a very powerful tool. We can use this for panel data, and as I'm going to show you in a second, we can also use it for variation through time. This is, I think, this is my favorite visualization tool, the scatter plot, because it's so incredibly versatile and powerful. We're going to use it a lot this semester. In fact, I would say this is probably our core tool for visualization. Okay. And then one thing we can do is actually just label using colors which countries are increasing and which countries are decreasing. And I'm going to show you an easy way to do this in Python in a second. Okay. So going back to our original question, does the data confirm that the world is drinking more coffee? I see a lot of people saying yes. Someone tell me why. Yeah.
Usually we can tell that using the line, a lot of countries have basically increased their consumption over the years.
Yeah.
So we can easily say that a good majority of the world has increased their consumption of coffee.
So during these 2 years, the 20 years that we're looking at, it looks like most countries have increased their coffee consumption per capita. The majority of countries are in red, telling us that coffee consumption per capita has gone up. And then there are only a few countries below the line that seem to have decreased their coffee consumption per capita. This is an incredibly powerful tool. Okay, and it looks simple, which is part of why it's powerful. It's powerful because we can turn seemingly complex relationships into something that you can easily ingest. You can understand this in 10 seconds, but it's a pretty complex set of relationships. Okay, so this is panel data in wide format. We're going to spend a few minutes just working with this kind of format. We're going to construct a scatter plot, essentially reproducing what we've just seen. And we're going to do this in both Python and Excel. Okay, y'all like doing exercises? Okay, that's not the enthusiasm I'm looking for. I know it's Tuesday. Let's break out our computers. So you can hop over to part 1. And then you can see I've also, if you refresh the page, I've also posted the videos. I was a little bit behind on that. If I ever get behind on posting videos, you can just go to my main YouTube channel and just find the live streams there. So you don't have to wait for me to post the videos to the course page. You can always find the live streams whether I posted them here or not. But here I've just broken them out for you to just have in nice little chunks. So we left off last time talking about the scatter plots. So I'll post that a little bit later. But you can just click on the notebook to get back to where we were. Or I know you all are working on your own notebooks on your own, but this is just what I've done in the meantime. And then we're going to start by working with coffee per capita. So I'm just going to download this. So this goes into the downloads folder. And then I'm going to open a I'm going to go to desktop, and then we're in part 1.4. And then I'm just going to drag over, as always, drag over coffee per capita into the part 1.4 folder, which gives us our CSV file in the folder that corresponds to the part that we're in. And we're doing this, just to remind you every time, we're doing this to keep ourselves organized. We're only in part 1.4. We have 6 parts this semester, and each part has at least 4 subparts. So we're gonna have 20 parts, 20 different folders by the end of the semester. And if you just let your files float freely in a folder, or even in your downloads folder, I guarantee you there will come a time where you won't be able to find the data set you're looking for. This allows you to always be able to find what you're looking for. It's worth the extra effort. Okay, so if you double click on this, it brings up this spreadsheet. I'm gonna hit save as, and then I'm just gonna save this as coffee per capita, which saves in this same folder. This saves it as a XLSX workbook. Okay, how many of you have done this so far? You've made it this far. Not everyone. This is not the level of engagement that I'm looking for. So I'm going to have you check your neighbor's work in a second. So what we're going to do essentially is create a scatter plot. We're going to look at the two different time periods. We're going to have an x variable representing our base year, and then on the y variable, we're going to have the 2019 year. So if you're constructing a scatter plot, anyone know where we might start? We're trying to look at which countries have increased or decreased their coffee consumption per capita. How might we start to create a figure here in Excel? Is that a hand? Yeah. And then, yeah, click on a scatter plot. Yeah, so we want to select the data that we're interested in, and then go into Insert, and then click on the figure that we're looking for, which in this case is scatter plot. Remind me of your name?
Jason.
So, I'm sorry, I've asked you for your name like 14 different times, and it's not Chase.
It's Jason.
Right. So Jason's recommending selecting the data that we're interested in and then finding a scatter plot. And that's the general process we're going to follow. So if we're looking between these 2 years, I would like to start with 1999, the year I can't pronounce. We can start by including the column, the 1999 as in the selected data. We'll come back to this in a second. But then we should also be able to select 2019 as the second data. And this is the last year that we have records for. So we have both of these data, these columns selected. Once you're here, you can go to Insert, and then click on Scatter Plot. And you see some options here. You can do a lot of fancy things, or you can try to do a lot of fancy things in Excel. In general, one of the best practices for creating nice visuals is to keep it very simple. At least at the very beginning, we want to keep it as simple as possible. So in this case, we're going to ignore all the other stuff and just click on Scatter. So when I click on Scatter, it looks like this. Anyone know why it looks like this? Did you all get this problem? Yeah.
Is it because the units go up to 2,500 but we don't exactly have that many units in our data?
Right, so we have sort of an axis problem here. The horizontal axis goes all the way up to, past 2,000, and then the same thing for the vertical axis. Anyone know why we have a data point that's that high? Do we know why this is? Like, what's this doing up here? This says there's a coffee consumption per capita that we're trying to plot. That's 1999 and 2019. Do we know what this is? Yeah.
It's the arrow. It's like the dates for the year.
So Excel doesn't know that we're trying to give the column names. So there are a couple of options here. I find the simplest one is to just not select the column, and then we'll come back to this in a second. Remind me of your name? Matt. So Matt's saying this is our date. There are a couple ways of doing this. One thing you could do is just go in here, click select data, and you could say there's this horizontal category axis labels. And one thing this could do for you is give you a column name. But I'm actually going to, we can select, we can just go in and select X and select all of this data for the X values, and then go in and select all of this data for the Y values, excluding the column names. And click OK. And that should fix our problem. So all we've done is made sure that it's not using the column names as data points specifically. Okay, anyone get this? How many of you were able to successfully create a scatter plot? Okay, if you haven't created a scatter plot, maybe check with someone next to you and they can help you out. But we can make this figure a little bit better. Anyone have any ideas for how to make this figure look more informative? Yeah, Luke.
You add a line of best fit.
So you could add a line of best fit if you wanted to. We haven't really talked about that, so I'm a little bit hesitant to add that in. We're going to spend a lot of time talking about lines of best fit. We just haven't gotten there yet.
Label the axis.
So we could label the axis. Yeah. So I'm going to go in, click on Add Chart Element. I'm going to go into Axis Titles, and I'm going to click on Primary Horizontal Axis. And our x-axis is 1999. So I'm going to say 1999 coffee consumption. And then I'm also going to add a title for the vertical axis. We'll call this primary vertical, and this will be 2019 coffee consumption. And then we could just change the title to be coffee consumption per capita. Okay, what else could we do here? Yeah. So yeah, 45-degree line could work here. I'm sure there's a way to do it in Excel. It's not something I'm so familiar with, adding a 45-degree line here. We can do it pretty simply in Python. Yeah, Darren.
Should we fix the scaling on the y-axis first?
Yeah, so we see two different scales differently on the horizontal and vertical axes. And this makes it pretty hard to see if there's an increase or decrease. So I believe we go in, let's see, double click on the axis. So if we go into axis options, we can click on minimum, and then we can change the maximum. We have a maximum on the vertical axis of 25, so let's change the maximum on the horizontal axis to be 25. And if we hit enter, then we get this figure. It's not square, so we could change I think it's easier to read if it's square. Wouldn't you agree? Probably square is easier to read with when we're using the same units on vertical and horizontal. Okay, so I think this is a pretty good figure. We've plotted 2 different years, same units, and because we have a panel, this gives us a measure of changes through time. All right, how many of you think this is easier to do in Python? Correct. How many of you think it's easier to do in Excel? As I've just told you that the other answer is correct. So this is probably a little bit easier to do in Python, but your mileage may vary. So what I'm going to do is hop back over to the notebook. We started this last time. I'm just going to load the imports and then the file path. I've closed the notebook since we've last done this, so I just need to reload it. And then I'm going to load coffee consumption per capita And then I just want to take a look at this before we get started. So it's kind of an overwhelming data set. Would you agree? This looks kind of overwhelming. We have lots of years, and we really just care about 2 of them. So yeah, I'd say this is somewhat overwhelming. What we could do here, if we're writing out our figure, before we copy any code from the slides, I want you to take a guess at what the syntax will look like here for a scatter plot. Anyone have an idea what we do first? Yeah, Ruby? Yeah. Dot scatter plot. Okay. And then what do we do? So let's hit tab and see what happens. It will say value error. Gemini doesn't quite know what we want to do. It does know that we want coffee as the data set. What do we want as the x variable? Yeah. 1999. So let's just put in 1999. And then what do we want as the y variable? 2019. And then I'm going to run this. Okay. I'd say that's no more complicated than Excel. What else might we do to improve this figure? Yeah, Jason.
Add a title.
Okay, so a title and then our 2 axis labels. Yeah, so Seaborn doesn't have the package to add titles, but matplotlib does, and I've already imported that for you at the beginning of the document. So all we have to do is I had friends in college also call me Tay-Tay before Taylor Swift got popular. I had that name first, just letting you know. So we've, just like my friends called me Tay-Tay, we've renamed matplotlib PLT, and then we're just going to write out title and just call this coffee consumption per capita. Look at that. Gemini does a lot of the work for us. Coffee consumption per capita. And then let's put as the X type label, PLT X label is 1999. So I'm going to hit tab. And we get an X label of 1999 and a Y label of 2019. Gemini can do a lot of this for you, but make sure as you use the tool that you understand what you're tabbing through when you construct it. All we're telling Python to do is, just like we go through in Excel and click on a bunch of stuff, telling Excel to add a title and an X label and a Y label, all we're doing here is just listing out the steps that we're performing in sequence. So I'm going to run this. And we have our X label and our Y label and our title. What's maybe another thing we might want to do? Yeah, Ruby. So we can add a 45-degree line. Yeah. Let's come back to this in a second. There's, I think, one more thing we should do before we get there. Yeah, Darren.
Fix the scaling.
So let's fix the scaling just like we did in Excel. So in Python, this is simple, just like all the other steps. I think a lot of times the difficulty with performing these steps is knowing which functions to call. I'm going to show you what the functions are, and then I'm going to show you how to get there if you're stuck, to help AI help bail you out. So here, I'm just going to say plt.xlim. So this is just setting the limits for the horizontal axis. I'm going to say I want it to go from 0 to 25, and then I'll run that. So now we just set 0 to 25 on the horizontal axis. And then I want you to, without using AI, to set the y limits. We'll take 30 seconds here, and then just check that you have your neighbor check that you did it correctly. Okay, so I'm just going to tab through and select what Gemini gave me. Essentially, we're just replacing x and y, and this allows us to set x and y limits. Okay, any questions here? So the last thing we'll do, it's a little more complicated. This is like a pro tool. I want a 45-degree line. So I'm going to write this hash mark, which tells Python to not run this line. This is just something to be read by the human. Funny we have to say that in this time. So 45-degree line. And then all Python is doing is using matplotlib with a plot function. And then we're going from this point to this point. And we're just going to color it red. So I'm going to hit tab. This is how we write with Python, with AI these days. We use comments to tell it what we think we want, and then Gemini will interpret that and write us a line of code. So you can use this in your homework, and I encourage you to become familiar with generally how these things kind of work. But just like calculators on your addition homework in elementary school, you have to understand the tools that you're using. So one of the tools that we use today truly is AI, and you have to be familiar with how the tools are used. But if you're just writing code without understanding what you're writing, that will create some problems for you. So I'm going to emphasize the sort of understanding the tools as we go. But for these more advanced things, this is not a Python class. I don't expect you to be able to write these kinds of lines. So sometimes we'll use comments to help us out. So if we run this, this gives us a 45-degree line. We can make it prettier if we want. So like change the line style to more of a dashed, or make it like this. And then the last thing we'll do, you may have noticed at the very end, it looks like that didn't update. We'll do some coloring later. But yeah, I meant to add a change column at the end to allow us to make some colors, but I think we'll save that for another time. Okay, any questions here? How many of you does this feel intimidating to? Raise your hand if you feel somewhat intimidated by these lines of code. And how many of you feel very comfortable with this? Okay, and then everyone else is somewhere in the middle. That's great. I love that. If you're feeling intimidated, that's you're in the right room. This is not we're starting from the ground floor. These things often take a little bit of time to become familiar with. If you're feeling in the middle, that's great. And if you're feeling comfortable, I love that too. Okay, so nice. This, I don't want to, before we move on to time series, I just want to emphasize what we've done. This is truly something special. A scatter plot, it may look like a trivial and simple tool. But in the scheme of things, this is one of the most powerful visualization techniques we have at our disposal. What we did at the beginning of the second part of the slides in 1.4 is we tried to ask a question that seemed impossible using some of the original tools we had. With box plots, you can't answer this question. This is not a question we can ask. Or it's not a question we can answer with box plots, even with a strip plot. But a scatter plot allows us to track individual countries through time, which gives us not just the cross-sectional variation across countries in their coffee consumption per capita, but also 2 dimensions of coffee consumption for each individual country. So we have our panel data, which gives us both the cross-section and the time series, which we can represent with a scatter plot. Okay, I think this is pretty amazing that we were able to do these kinds of things. Okay, and then sort of some of the summary here. We can look at changes in the distribution itself. With box plots, we can't observe individual changes. Scatter plots allow us to do that, and then a 95-degree line, sort of a 45-degree line, allows us to visualize the changes. And then we can also use colors, which I'll show you in a second. Okay, amazing. Scatter plots are not just useful when we talk about panel data. They're also maybe primarily useful when we talk about relationships between cross-sectional variables. We're going to spend a lot of time this semester talking about cross-sectional bivariate data. So that's where we're turning in the last part of class here. So part 1.5, we're talking about bivariate data, which we've sort of already introduced with panel. But we're going to talk more systematically about how to interpret scatter plots. And then I'm going to preview some of the things that are coming in part 2. So let's say I have this data set. I have 2 variables. I have GDP and coffee production. And I have 2 histograms here. And I were to ask you, is there a relationship between countries with higher GDP and higher coffee production? Do countries with higher GDP produce more coffee? Two histograms. We've summarized the 2 variables separately. Anyone want to take a guess at this? I put you all to sleep. Luke, except Luke.
Can't really tell.
2 histograms, we can't really tell. Yeah, so very similar to last time, yeah.
I think in the first study, there's a reasonable correlation, there's no causation. Is that?
Okay, so you're seeing a correlation here.
Well, I think if we had more data points, it would be easier to tell and actually say with confidence that there is.
Okay.
I think just from the 2 data, if you were to put them on the same graph, I would say that there is.
Okay, so maybe we put them on the same graph and check. And we will talk about correlation and causation at the end of the slides. Yeah, so I would say it's hard to see the relationship from this figure. So let's put the 2 variables on the same graph. We've already introduced the scatter plot. Let's just use that. Why don't we use a graph like this? So I have a bunch of points, and I've connected them with a line, just like we did with line time series. Why don't we do this? Is this informative? Why is this not informative? Why do we use a line graph with time series, but we don't when we use cross-section? Yeah, Alexis.
This isn't like matching words, but if you're looking at different countries, you're not like, if there's no reason for them to connect or they're not related to each other.
That's exactly it. Alexis is saying these observations in cross-section are not connected to each other. It's not the same unit of observation. We have multiple individuals at one point in time, which are unconnected. With a time series, we plot them in with a line graph because it's the same unit of observation through time. It's one entity. Here, these are not the same entities, so we don't plot it with a line. This actually obscures the separation between the individuals. So instead what we do, as Darren is recommending, is plot this as a scatter plot. On the horizontal axis, I have GDP per capita, or just GDP in trillions of dollars. And then on the vertical axis, I have coffee production in billions of kilograms. So now my question back at you. Is there a relationship between coffee production and GDP? I think this is maybe a little bit hard to read. We have a lot of data points that are clumped up around the bottom here. So it's hard to tell if there's if there's a relationship here. We can definitely see that it seems like the further you move out on the horizontal axis, the further you move up on the vertical axis. But before we try to talk about trends like that, or relationships between these two variables, let's just think systematically about how to read a figure like this. So one question we could ask of the data is, which countries have a GDP above $2 trillion? Take a second. I want you to identify on the graph which countries. This might seem like an easy question. If it is, that's great. Which countries, and maybe how many of them, have a GDP above $2 trillion in our data set? Take 30 seconds, tell your neighbor a number. Okay, someone tell me a number. Sophia. 3. How do we find it? So on the horizontal, how many are to the right of 2? And it's this one, and this one. Okay. So we've identified the countries with the GDP above 2 trillion. What about this one? So we can use this kind of comparison both on the horizontal and the vertical. So let's take a second here, try to answer this question. Which countries have a production above 1/2 billion kilograms? Maybe try to count them up. And maybe the answer is, if you're asking me about 1/2, why haven't you labeled it? Yeah, good question. Okay, so I'm going to say it looks something like this. These two are just slightly below 1/2. Any quibbles? Maybe better horizontal ticks, or vertical, horizontal ticks would be helpful. Agreed. So we can identify values on the horizontal and vertical axis just as we would expect. We can also make comparisons between points. So just like we used some extra tooling using the 45-degree line, we can do the same thing here. So I've identified Brazil, and my question for you is, which countries produce less coffee per dollar of GDP than Brazil? So this is a slightly more complicated type of question. We'll take about a minute here. I want you to try to maybe pinpoint what region of this graph corresponds to the countries that answer this question. Which countries produce less coffee per dollar than Brazil? Okay, how many of you have an answer for me? A few? Okay. Someone want to try to answer this? Someone other than Jason. Someone other than Darren. Okay, Matan, yeah.
So I'm not sure, but I think it's those four. Here, go down one.
Down here.
That one.
This one?
Go that one. Go to the left a little. That one and that one. Those are the obvious ones.
Okay.
Like
And then maybe some of these too.
it's hard to tell over there, but
Yeah.
anything where the line from the y-axis to it is longer than the line from the x-axis to it.
Okay, so yeah, looking at the ratios of x-axis to y-axis. Yeah, so Matan is pointing out maybe it's some of these. And then maybe also some of these. Someone follow up on Matan's answer here. How might we think systematically about answering this question? Like what part of the graph? Yeah.
Like if we were to add a line of best fit and then see the points fall below it.
Okay, and how would the best fit line be drawn? Like,
Like from 0, 0 up through Brazil.
okay,
To Brazil.
so nice. So remind me of your name?
Ava.
Ava. So Ava's saying we're going to draw a line from 0, 0, the origin, up to Brazil. So a line that runs from here to here. Let's actually just plot that. So we have this line which represents every possible ratio of GDP and production of coffee. Just like we did with the 45-degree line in the previous example, this line represents every ratio of GDP and coffee production that's equal to Brazil. And all we have to do is identify the points that are on one side of this line. Matan and Ava both gave me an answer here. Someone try to articulate which side of this line answers this question. Yeah. So produces less coffee per dollar than Brazil. Or another way of saying this is more dollars for the same amount of coffee. Remind me of your name? Jake. J, I'm sorry. Like the letter J. Yeah, got it. So Jay's saying everything below the line would be more coffee per dollar than Brazil. Any questions here? Nice. We could call these separating lines if we like. We did something similar with a 45-degree line before, but it doesn't have to be 45 degrees. We can set these up really in any way we like. All right. And then we can just do the same thing on the other side. So if we're looking at more coffee per dollar than Brazil, then it would be these countries. So we can make comparisons between ratios. So essentially these lines represent some constant ratio across a bunch of horizontal and vertical values. I'm going to ask you maybe 2 or 3 more questions, and then I'll send you out the door. We're going to work with these things a little bit more in the next, next class. But let's say I were to ask you this question. Do the GDPs of the upper or lower pair differ by a larger amount? So it's a little bit hard to see here. Why are your figures so bad, Taylor? This is Cameroon and Malawi. They're both coffee-producing countries. And then this is Thailand, and this is Brazil. My question for you is the upper pair, does the upper pair or does the larger pair differ by a larger amount? So does Cameroon and Malawi, do they differ in coffee production, in GDP on the horizontal axis, by more or less than Thailand and Brazil? Take maybe like 20 seconds here. Upper pair or larger pair have a larger difference? Just give your neighbor an answer. Okay, is this a simple answer? Someone tell me. Luke.
The difference between Thailand and Brazil with respect to GDP is larger.
Okay, so the difference between Thailand, which is roughly 1.2 maybe, and Brazil, which is like 3.1, that difference is pretty large. Where the difference between Cameroon and Malawi is so small, it's impossible to read it on this figure. So we can use the horizontal axis to measure differences. What if I were to ask you this question? Which is larger, the ratio of the GDPs of the upper or lower pair? So we take Brazil's GDP, we divide it by Thailand's GDP, then we take Cameroon's GDP and we divide it by Malawi's GDP. Take a second here. Okay, someone give me an answer. Someone other than Luke. See it? I appreciate it. Yeah, Jason.
It's kind of hard to tell what it's coming from.
Okay. And why is it hard to tell?
Because you don't know what the exact numbers are for Cameroon and Malawi.
Malawi.
So like, it's just hard to tell like what those two numbers could be because
Yeah.
it could be greater or less than that.
Yeah, it's hard to tell here. I think for two reasons. One of them, Jason is saying, like, it's hard to see what those numbers actually are. And then second, if we were able to see them, we would still have to take a ratio in our heads. And that's kind of challenging to do. Next class, we're going to talk about a way of actually visualizing ratios, which makes it very simple to answer this kind of question. Homework 1.5 is posted, and then homework 1.6 will be posted later tonight. I will see you all in office hours tomorrow.